Hello everyone. In a previous video under descriptive measures, we learned about measures of location. In this video, we are going to talk about measures of variation. Up to this point, we have discussed only descriptive measures of center. However, two datasets can have the same mean, median, or mode and still differ in other respects. To have an idea, let's look at the following example. Here we have two teams of basketball players, and the team 1 heights and team 2 heights in inches are given in the table. If we look at team 1 heights, it's 72, 73, 76, 76, and 78. Team 2 heights in inches, 67, 72, 76, 76, and 84. If you calculate the measures of location for these datasets, for these two datasets, you can see that all the measures of locations that we learned up to now, that means mean, median, and mode, are same for both the datasets. If you calculate the mean height for team 1 and for team 2, you will see that it is 75 inches for both the teams. And similarly, if you calculate the median, it's 76 inches for team 1 and team 2. And the mode is also 76 inches for both teams. But we can see that the heights of the players on team 2 vary much more than those on team 1. In order to describe that difference quantitatively, we use a descriptive measure that indicates the amount of variation or spread in a dataset. And such descriptive measures are referred to as measures of variation or measures of spread. And under this section, we're going to learn about three most frequently used measures of spread, and they are range, sample variance, and sample standard deviation. First, let's look at the range. Range is nothing but the maximum or the largest observation minus the smallest observation in your dataset. Let's look at an example. If you try to calculate the range for team 1 and team 2 separately, team 1, you'll get the range as 78 minus 72. Here 78 is the largest or the maximum of dataset 1, and 72 is the minimum observation in dataset 1. So 78 minus 72 gives us the range as 6 inches. And similarly for team 2, the highest value is 84 and the smallest is 67, and 84 minus 67, which is 17 inches, becomes the range for team 2. The range accounts only the largest and smallest observations. Therefore, it is not a very good measurement, because even though if you have thousands and thousands of data points in your dataset, the range will only consider the 2 points, maximum and the minimum, for its calculation. So, we move on to sample variance. The variance S squared of a data set of a set of observations is an average of the squares of the deviations of the observations to the mean. And the equation is summation xi minus x bar, which is the sample mean, and then you square it and divide by n minus 1. It is denoted by simple S squared. Finally, the sample standard deviation. The standard deviation denoted by S is the square root of the variance. So we will have the same equation as before for the variance, but we are taking the square root of that one. So summation of xi minus x bar squared divided by n minus 1 and finally taking the square root will give us the sample standard deviation. Note that the sample variance and sample standard deviation is calculated considering all the observations. If we compare it with the range that we came across earlier, range took only 2 observations into account, whereas sample standard deviation and sample variance takes all the observations in our dataset into account for the calculation. Sample standard deviation is the preferred measure of variation when the mean is used as the measure of center. For a dataset with a large amount of variation, the observations will, on average, be far from the mean. So the variance or the standard deviation will be large. For a dataset with a small amount of variation, the observations will, on average, be close to the mean. So the variance or standard deviation will be small. Here are some important notes. When calculating sample variance and sample standard deviation, we divide by n minus 1. We do not divide by n, but we divide by n minus 1. Although dividing by n seems more natural, we divide by n minus 1 for the following reason. One of the main uses of the sample variance is to estimate the population variance. Division by n tends to underestimate the population variance, whereas division by n minus 1 gives on average the correct value. Now let's look at an example. Consider the heights of the students in Team 1, which are 72, 73, 76, 76, 78, and 75. And calculate the sample variance and sample standard deviation for this data set. Here's the answer. First, we'll calculate the sample variance. Then, we can calculate the sample standard deviation just by taking the square root of the sample variance. Let's create a table to make our calculations easier. In the first column, we have the observations, which are 72, 73, 76, 76, and 78. In the next column, we have xi minus x bars. This column is calculated by subtracting the mean from each observation. In the next column, we have the squared xi minus x bar. So it's just the squared value of the second column. And the summation of xi minus x bar squares can be computed by summing up the third column, and it sums up to 24. So the sample variance S squared can be calculated as summation xi minus x bar whole thing squared, which is equal to the summation of the third column, which is 24, divided by n minus 1. Here n is the number of observations in your sample. Here we have a sample of size 5, so our n is 5. So we can calculate sample variance as 24 divided by n minus 1, which is 5 minus 1. So 24 divided by 4 will give us the answer as 6. And the sample standard deviation is the square root of this answer, which is square root of 6, and it is approximately equal to 2.4 inches. Finally, we are going to talk about a simplified formula for the variance and standard deviation. Original formula for variance and standard deviation can be further simplified. This new version of variance and standard deviation is computationally more convenient and easier to compute formula for variance and standard deviation. The formula for variance is summation of xi squared minus the summation of xi whole thing squared divided by n minus 1. And the standard deviation is the square root of the above statement, above expression. And we can try the previous example using the new formula. You can check the answers, and the answers should be the same. Thank you.